for our first question. This is similar to question 5. Try to make this work before I do anything. There, that'll work. Okay, that's a version of 5. 2x take away 14 over quadratic. Now, I know that's going to be a partial fraction, but actually I've got an extra step. Do you notice that that bottom isn't factored, so I won't be able to break it into fractions until it is? There we go. Okay, now we're ready for partial fractions. I'm going to put that guy over here. And let's just fix this guy. So this is, I guess, like my working on the side. Would you agree this breaks into 2 partial fractions? An x minus 2, and the other baby fraction, an x minus 3. So far, so good. If you remember yesterday, isn't the next thing we need to do is to put them all back together again. In this case, that guy gets an x minus 3, and this guy gets an x minus 2. So we now have this fella plus this guy all over this fella. And it's equal to that one, right? So you take your fraction, you break it into 2 pieces, you then take your 2 pieces and stick them back together again. And now we can do that little sneaky trick of saying that the tops, the numerators, must be equal. And now it's a matter of choosing x's. Hopefully from yesterday you're picking up some ideas about some values of x are very useful and others don't help. Give me a value of x I could choose in this story.
2.
And you're picking that one because it gets rid of this term, doesn't it? So if you choose x equals 2, 2 times 2 is 4, 4 take away 14 leaves you negative 10. If you put in 2 here, you basically get negative 1. If you put it in here, you get 0. So negative a equals 10, so that makes a equals 10. And that's good news. So far, so good. Then what I now do is I rewrite my information. Like this. Basically what I'm doing is, if I know a is 10, can't I replace it by 10 now? In this particular situation, it really doesn't matter, but later on it does for other questions. Okay, I need to choose another x, don't I? Who's a good idea this time?
3.
I would. And if you choose 3, 2 lots of 3 are 6. 6 take away 14 is negative 8. This becomes 0. And this becomes 3 take away 2, which is 1, which is b. Oh, I don't need to do any work. I got it already. Well, that means that we now have the integral of a 10 over x take away 2 plus the integral of b, which is, well, I guess I could put the negative there, and that way it's 8 over x minus 3 dx. Basically, I just split it into two integrals. There's my first partial fraction, negative 8. There's my second partial fraction. Each of these partial fractions we can integrate, can't we? Right, let's look at the 10 guy. 10 over x minus 2. What do you get for its antiderivative?
10 natural log x minus 2.
Take away 8 natural logs of x minus 3. Add c. Now, let's just say that this fella, this particular one, was 0 to 2. Then that would disappear, wouldn't we? And we'd get x equals 0 to x equals 2. And something, can I change that to a 3? So what do I get? I get 10. The natural log of 3 take away 1 is 1. Subtract 8. I get that. And if you do the other ones, you get some other fractions. What do you do with that? Because this is one of the few times where that absolute value thing that I tend to ignore comes in. So you will make that log 3. So if you're ever plugging numbers into a log expression, we'll use the assumption that all of these logs have those absolute values around them, just to make sure that we don't get caught out with a negative number. Because you can't get the log a negative 3, but you can for 3. So just watch out for that when you're doing the numerical part. Are we good with that one? Right. Now, moving on then. It's going to be version question 6. It's going to be the integral of 2y squared plus y plus 1. And on the bottom, it's going to be y plus 1, y take away 2, dy. So over here, I'll do the partial fraction thing. There's going to be a y. There's going to be a y plus 1. And there's going to be a y take away 2. I'm going to call that A. I'm going to call that B. I'm going to call that C. So far, so good. Now, this gets a little bit messier and bigger. Don't we have to combine 3 fractions so that they now share a common denominator? Now, when it was 2, it was a little bit easy. When it was 2, don't you multiply this guy by y plus 1 and this guy by y, right? They basically use what they don't have. What am I going to multiply a over y by to get it to be this fella?
y plus 1
y minus 2.
Yeah, we all agree on that. Basically, don't you just use the bits it doesn't have? So that middle one has a y plus 1. The bits it doesn't have are those two bits. And this one has a y minus 2, and the bits it doesn't have are those two. Which means we now have A, y plus 1, y take away 2, plus B, that's this guy, plus C, this guy. And now I'm going to save a line of work in. Technically, shouldn't I do a big line with that underneath it and then write this beside it? And then we make the bottom line disappear. If I take all of that in one go, are you happy with me just saying that is equal to this? Right. We want to try and reduce, in a normal homework situation, reduce the workload. Right, it's time to start picking. I need an X. Actually, there are 3 good X's. I'm saying X. Oops. I need a Y. That's the only difference, it's a Y. I need a Y. There are 3 good values of Y here. Any one of them in any order is fine in this particular question. So
2.
Give me a Y value.
2.
2. Won't that basically kill this fella and kill this fella, and that's the only one that's going to make it alive? Because if Y is 2, this is 0. If Y of 2, this bit is 0. So the only bit that isn't is that bit. So 2 lots of 2 squared is 8. Add 2 is 10. Add 1 is 11. So we get 11, and it's going to equal to nothing plus another nothing. And 3 times 2 is 6. So you're going to get, there's your C. Now, provided all the terms are linear, you can just keep going. In other words, you don't actually need to rewrite it with C equals 11, 6, although it wouldn't harm if you did. Give me your second choice.
-1.
I hear -1. Now, if I do -1, won't it make this bit 0? And it'll make this bit 0, and that's the only one that's going to make it. So here goes. 2 lots of -1 squared are 2. Take away 1 is 1. Add 1 is 2. -1 here makes that 0. -1 here makes that 0. And -1 in the middle gets you -3. -1, -3 is +3. In this case, B is 2/3. Agreed? Right, we've got one last guy to choose. There's only one left, right? So who's going to do the job this time?
0.
And if you use 0, won't this disappear to 0 and this disappear to 0? So this is the only one left alive, which is what you'd expect. 0 squared, 0, 0, you get 1. You plug it in here, you get 1. You plug 0 in here, you get -2. So it's what, -2a plus some zeros. And we are left with a is -1/2. So this integral here gets split, and it gets split as an a. So it's a -1/2 over y. Plus a b, which is 2/3 over y plus 1. And then a c, which was 11/6 y take away 2. Can I ... this? Isn't that going to be a half log y? 2/3 the log of y plus 1 plus 11/6 the y log of y minus ... Do you see? You're just going to get 3 lots of 3 various and ugly logs and a plus c at the end. We're good with the ... I mean, the hard part was doing this, right? Once you get to here, the integration in a lot of questions at least, it's going to be pretty much straightforward. Where shall I go next? Do a version of 9. Is there anything I should be doing to 9 before I can even start the partial fraction stuff?
Factor out the x on the bottom.
Right? Okay, let's do the partial fraction stuff now. How many partial fractions does this thing split into? How many pieces?
2.
Yeah. And won't the first one be x? And won't the second one be x squared plus whatever the number is? 1, right? So far, so good. Now, what goes in the top when it's an x squared plus 1 on the bottom? Talked about it
Bx plus c?
Yeah, just keep going through the alphabet. Are we good with the splitting? Now, this guy is going to get an x squared plus 1 into it. And this guy is going to get an x into it. So when we put this together, we're going to have a x squared plus 1 add bx add c times x. And that's going to be x squared take away x plus 6. Are we comfortable with that? Because I've kind of skipped a line. But basically making the tops equal, right? And once you get to that, it's pretty much now, in the earlier questions we did today, it really didn't matter which one you picked first, second, or even third, because they all worked in any order you like. But in these kinds of questions, the ones that have squares in them, the order that you choose the x's is almost as important as the x values that you choose. So who do I choose first? What x?
0?
Hesitant, but correct. What's good about 0?
It just leaves us with a and 6 on the left.
Right. So basically it destroys 2. Your goal is to choose an x that only leaves one of the variables, a, b, c, whatever it is, only leaves one of them behind. So if you choose 0, nothing take away nothing add 6 gets you 6. A times nothing squared plus 1 is basically 1. That guy is a whole load times nothing, but it's basically nothing. And that tells me A. Now, in any question where there's things like x squared plus 1s, as there is here, right, then you need to, in your next line, it's important that you do this. That you replace the A in this case by its value. If you keep that as A, the next step won't work because you'll end up thinking, I've got another variable, I don't know what to do, and you start just freaking out. Another reason for doing this, it's a little bit easier to see what's left to be found if it's a letter, right? Can you see that there's a B and a C still to be found, right? So now we can focus on another choice of X. One choice only, right, is going to help us. Anything else ain't any good. What's the X this time? Oh, I just saw something. I didn't realize that I'd...
Could I do 1 over B?
Ooh, a good idea, but no. No, I just realized the question had been written down differently than it is in the book. And I think that's what's generated this. But nonetheless, we'll have to figure it out. In this particular combination, what I was thinking should happen, it actually didn't happen, and it didn't happen because of this bloody bugger here, is that 0 would have been a good choice. But the problem with 0 is it kills everybody. Normally, this guy here is X plus 1, right? X plus 2, and 0 works fine. But I just discovered an awkward one. So it lends me to, well, what do you do when nothing obvious works? Plan B. Pick an X of 1. Now hold this thought, because it might look like it ain't going to work, but it is. 1 take away 1, that gets me 6. That gets me 12, right? 2 times 6. 1 here gets me B plus C times 1, which is that. And if I rearrange this a little bit, I'm actually going to keep this question because it shows something. Well, you might say, well, that ain't any darn good because I've got 2 variables and I don't know the answer. But that's only because I'm only halfway through. I'm now going to choose -1. And -1 is 1, -1 is 1, that becomes 8. -1 is 1, that becomes 12. -1 here gets me negative B plus C times -1. So I now have B take away C, and that's -4 equals B take away C. So I chose actually any 2 x's as long as 0 wasn't one of them. I've actually chosen 1 and -1, and I have 2 equations. And I want you to think back to Math 94. If I write these 2 equations next to each other, maybe you can see where things are going to go.
Is it a system of equations?
It is. And how do you solve a system of equations that look like these 2 guys? Come on, get the cobwebs out there. You add them.
Asking us? Oh, sorry.
Yeah. Which tells me, after a lot of work, I got B. Now that I know what B is, how do I find A? Oh, sorry, C. Math 94 again.
Substituting it to one of the variables.
Right, so if I plug it in here, add 5, you end up with, I'm doing it in my head, so it's dangerous, but I believe you get that guy. I actually kind of like this question, although it was accidental. I guess what it shows me is that the technique that we've got is, it works. But don't you sometimes you have to just, adapt. Hey, I can't use 0 because 0 ain't any good, and that's the guy I normally would use in this situation. Okay, how am I going to figure out B and C? Well, let's just pick 2 values of x, 1 and -1. Do you know I could have picked 5 and 42 and it would have worked? It would have been horrendously ugly system of equations, but it still would come out with the same answer. So that means this guy over here is now A, which is this guy, plus -5x, that's B, minus C over x squared plus 1. Well, that's going to become 6 over x. Then it's going to be this guy over x squared plus 1. And then it's going to be this guy over x squared plus 1. So what you do in the quadratic world is, although you have bx plus c, separate them. Let's see what we get here. That guy is going to get me some logs. This guy here is going to get me an inverse tan. And I have got this ugly guy in the middle. This ugly guy in the middle is, we need to do some work. How am I going to find the integral of this fraction? What method will I use?
U sub.
Yeah. And I'm just going to have to dot, because that's the question. You cannot integrate that directly. You can't just say, oh, I know the answer, because you don't. You're going to have to do a U sub on that. Now, do I know the answer to this? Yep. Do I know the answer to them? Yeah. But especially the x squared plus 4s, the x squared plus 1 guys, in this partial fraction, you're almost always going to get a 2x in the top or a 7x, in which case this U sub is going to be pretty much all the time for one term out of 3. Are we good? It's actually, I kind of like that question. Note to self, keep it. Now, we've done an x squared, we've done all sorts of other guys. There are 2 more situations that I want to make sure I've covered. And that one is, yeah, this is a version of question 7. It's going to be the integral of x squared plus x plus 1, which isn't a big deal. But it is going to have that guy, right? An x plus 1 squared guy. So let's see if we can deal with that. Now, I know we only touched on it yesterday. I hope you remember that this actually generates 3 partial fractions. You have an a over x plus 1. You will have a b over x plus 1 squared, and you'll have a c over x plus 2. Do you notice that there's 2 terms with x plus 1s? That's what happens when you have an x plus 1 squared. This are the 3 baby fractions that you always get. So far, so good. Okay. Now I need to convert these to share this common denominator. What's this term got? Well, it's got 1 of these, but it doesn't have 2. So it's going to be an x plus 1, x plus 2. The middle one's got all of that. So the middle one's just missing an x plus 2. And the end one Isn't it missing an x plus 1 squared? Are you happy about the extra bits that each one gets? You get the bit you don't have, right? So that tells me that the top is equal to A, x plus 1, x plus 2, followed by a B, x plus 2, and followed by a C, x plus 1 squared. And we are still, because all the methods are the same, we are still going to do the choose an x equals.
Will the 1 plus x and the a have a square?
Let's see. This one here.
Yeah.
A and a.
Well, it had one, so it only needs one more.
Oh, okay.
Right. So if you look at it, there should be two x plus 1s and an x plus 2. He's got one of them, so he's only short of 1 and an x plus 2. This one's got the square bit, it's only short of an x plus 2. And this one's got an x plus 2 and it's short of an x plus 1 squared. So that's it. Right, time to start picking. One good x, nothing else will do. Who are we picking?
-2.
Okay then. That's 4, take away 2 is 2, 2 add 1 is 3. -2 is killing that guy, -2 is killing that guy, and -2 add 1 is 1, -1 squared is C, and we have got our first guy. So I have x squared plus x plus 1 is this fella, this fella, this fella, and 3 lots is that guy, right? And that helps us also to focus on who to go for next. Give me another x, only one at a time. So who do I want this time?
One.
You want to rephrase the one a little bit,
one.
just, yeah. -1 squared is 1, take away 1, that becomes 1. -1 kills that. -1 kills that. And -1 here gets you 1. And that tells me who B is. So we now have x squared plus x plus 1 equals A x plus 1 x plus 2 plus 1 lot of B plus 3 lots of that guy. So we are into our last choice. It's actually easier than it might seem to you, because in a way, won't any value of x work as long as you don't pick these two?
-1.
-1 is chosen, so I can't use him.
Oh, you can't use it again.
Yeah.
Oh.
So anybody.
Just do one.
Oh, you lack of them. Yes, 1 will work. Come on. Even easier than 1. You know how bad I am at counting, right? Pick 0, but 1 will work. I tend to screw up less when I do calculations with 0. So 0 plus 0 plus 1. 0, 0, that's 2. That gets me 2a. That gets me a 2. That gets me a 1 squared times 3. That gets me 3. What does that look like? It looks like 2a plus 5, which means a is -2. Now, would 1 have worked? Of course it would. 42 would have worked. Actually, if you ever get to the stage where there's only one missing letter, as we have here, as long as you don't choose this number or that number, everybody else will work. But I like 0. So if that's an option, I would pick it for me. Right, so what does this guy become? Well, he becomes an a over x plus 1. So that's a -2 over x plus 1. And I'll put a little dx on that. I'll separate them as we're doing it. And then we have a b. So that's a 1 over x plus 1 squared. And then we have a c, which is a 3 over x plus 2. So I'm basically, right, there's our 3 partial fractions. Now I know the answer to that is a log. I know the answer to this guy is a log. How am I going to do that guy? I need to integrate that guy.
U sub.
And make the u sub x plus 1. And it'll work out nice. Have you noticed in these square questions, you probably are going to have to do a u sub at the end? You know, like the x squared plus 1 thing tends to generate a u sub. And that an x plus 1 squared, you know, is probably going to generate a u sub. So you expect it to happen, so it shouldn't be a surprise. The other two tend to come out pretty straightforward. We go with this guy. So I've done an x squared plus 4 story. I've done an x plus 1 all squared story. And we've done, you know, an x plus 1 with an x plus 7 kind of story. So where are we off to next is u subs. What do you mean u subs? Yes, they are going to mix partial fractions and u subs. So this is like question 10. And they even tell you to make a substitution, which is their way of saying do a u sub. And do you know we have lots of rules about u subs? You know, the guy inside the ugly square root is the u sub, you know, so on and so forth. And I'm sure I said to you that there's special cases. There are just some situations where the obvious u sub doesn't work. An example of that might be log x over x, right? That would be an example of special. This here is an example of a special case. So hopefully when I show you this one, you'll be able to see it the next time and do a similar situation. A weird u sub. What on earth could that be? In a way, this breaks all the rules that I told you about, because it's the special case. U subs of x basically just turns, if we'll get 2 dx's here, just turns everything into du u square root u minus 1. So that's not the one I'm thinking of. Oh, that's pretty weird. Something even weirder than that.
Is it dx?
No, that would be really weird. I'm not even sure how that would end. But yeah, you're on the right thought process, but go away from that weirdness and find a different weirdness. Anybody coming up?
Did we just do the whole denominator?
Wow, that would be a weird one. And I can imagine a different question where that would have been exactly the right thing to do. And you were half right. that U sub. Now, superficially, that U sub looks like it hasn't got a chance in Hades, right? That is just not going to cut it. But trust me, it is. First thing I'm going to do is write it like that, because I'm going to have to differentiate. Now, if you differentiate with respect to x, you will get multiplied by the power, reduce the power by 1. You agree? So far, so good. Now, because it is a little bit weird, I'm going to set it up a little bit differently. Would you agree it's the same thing as that? Right, I'm just taking that and making it positive. And now, it's that guy. And now when I do the crossover, I get this fella. Do you see the isolated dx is this? So let's see what this looks like. Dx is 2 square root of x minus 1 du, and over an x, the square root of x minus 1. And we are left with 2 over x du. Oh, this is good. But you should be going, oh, that looks really nice. Then that blinking x, no good. Doesn't x have to be written or replaced by things with u's? Right? This has to be everything in use. So I'm going to take my u sub. I'm going to do some algebra to it. If you square both sides, you get that. And if you add 1 to both sides, you get that. So far, so good. Which means that this guy becomes that. Actually, I don't need partial fractions for this one. Don't we know the answer? Great. And then this is a straight copy out of the book, or the homework. They missed a really big opportunity here. Do you know if they just made that x plus 1? Right, see this thing? If they'd made it x plus 1, can you imagine I went through the same process? What you would have ended up with would have been a much nicer looking answer. It would have still looked like that, but the x would have ended up being u squared minus 1. Can you trust me? If you made this a plus, that's what you would have got. And that would have become and wouldn't that have been a partial fraction question? So I just wonder if they screwed up there, because I'm looking at the answer and it's the same as the original, right? But I think they missed an opportunity there. They could have made that a much more interesting question. But we take what we get. Are we good? Right. Next one I do know, because I've already looked ahead, is going to come out much nicer. We have an e to the x. We have an e to the x take away 3. And we have an e to the 2x add 1. And we have a dx. Got to think outside the box. Give me a U sub.
E to the X.
Good choice. If you differentiate with respect to X, if you do the crossover, and if you isolate the dx. Things get a little bit messy here, but here goes. I'm going to leave that e to the x just for a little while. I'm going to turn the dx into that bit. And now I have two guys, this fella and this fella. Well, right now, I'm just going to, for one extra line, leave him alone. That guy cancels that guy. Won't this become u take away 3? And what will this guy become in terms of u?
U squared?
Do you see a normal partial fraction question in terms of u? You see it? Don't have time, but ... You do partial fractions, you get an answer with a whole load of u's. Turn all the u's back in e to the x's. When you're finished, then you've got the answer. So that's a much better example of a u sub becoming a partial fraction. And I'm looking at the answer here and it's horrendous, but it is what it is. And we have some more questions that we'll have to do tomorrow. And then I'll tell you about tables of values.
Can we get help
Right.
with the homework afterwards?
Sure. If you need any help with homework, hang about. Will you all say hi before you disappear? As soon as you've done that, goodbye.
I was wondering if in the homework we could go over a problem where the degree of the numerator is greater than the degree of the denominator.
Yeah, so we have to do a long division question because that's what's going to happen.
Oh, okay.
Okay. So I'm looking at one right now, which would be 13. So if you're interested, you can hang around. Oh, well, in 13, they just say, is it true or false? So I guess that's not that helpful. Let's see if I can wind back and find one. Have you got a number, a question number that does that?
I can find one.
I think 4, the first part of 4 has one.
Okay. So in question 4, then, I have an x to the 4. I take away 2x cubed. Good grief, it goes on forever. At least that's my version of it. And we're basically going to break this down into what its partial fractions would look like. So that's a long division.
We can't see your paper.
Oh, great. Let's have a look at this guy. Okay. Cover up everybody except that and that. So x squared needs to become x to the 4. We do that by multiplying it by x squared. That's the first step. Then we multiply everybody here by that guy. So you're going to get an x to the 4, a minus 2x cubed, that was a surprise, plus an x squared. That was an even bigger surprise, because normally it doesn't come out that nice. And then you put a big bracket around it and subtract. That, take away that gone, that gone, that gone. So all I'm left with is a 9x take away 4. So this fraction up here, this guy here, is equal to x squared with the remainder of this fella. Don't expect all three terms to go. Do you know, normally you do an x squared and a 4x, then a plus 2, and then you would be finished. But not in this case. It came out really quite surprisingly nice. This isn't finished. This has to be turned into a partial fraction, but the x squared part is good, the quotient part. Don't we have to factor the bottom if we're going to use partial fractions? X squared take away 2x add 1. How does that factor out? X squared take away 2x
X
plus 1.
minus 1 squared.
Yeah. So that means we're going to have an a over x minus 1 and a b over x minus 1 squared. Now, if you were going to integrate this, right, if that was the original question, right, integrate this, wouldn't it just become the integral of this fella? And we'll assume that you've found what a and b are numbers. Can't you just integrate in the usual way once you do that? So it's long division first, maybe a bit of factoring, and then partial fractions.
Okay,
Right, we
thank
got,
you.
yeah, we got another question. Anybody? Then that's it. Call it a day. And if you have more questions, ask me tomorrow.
Thank you.
You're welcome. Do you mind, guys, if I keep that as part of the work? So when people look at the video, they can see it? Nobody got
Go
a
for
problem
it.
with that? Thank you.